All right, this is page 26 of the 2018 math portion of the ACT practice test, and we're going to go over solutions for 17 through 27. So starting with number 17, we want to find the slope of the line that's given by this equation 4x equals 7y plus 5. So typically it's easiest to find the slope of a line when an equation is slope-intercept form. And really what you're looking for is if y is isolated, then you can easily find the slope by looking for the coefficient or the number that's multiplying x. So currently our equation is not in slope-intercept form because y is not isolated. So what I can do is I can go ahead and isolate y. Currently, I can move the 5 over to the other side. To be honest, you can kind of do this problem without doing that, but I will move the 5 over to the other side. Notice the sign change. And then I will divide all three terms by the 7 so that y is isolated. And when I do that, I get that y is equal to 4/7 x minus 5/7. And the 4/7 is the coefficient of x, which tells us it is the slope. So my final answer here is B, positive 4/7. Number 18, we want to decide for which condition will we always have odd integers. It needs to always be odd integers when we are adding. So if m is an odd integer, maybe I'll make m some number like an odd number like 3. I'm trying to make sure that I add up m and n and I get an odd number. Well, if m is odd, that's not enough for me to know that I would for sure get an odd number when I add other things on, because if n is, for example, an even number, that would give me an odd. But if n is another odd number, I get to an even. So the fact that m is odd by itself is not going to be enough evidence to know that I would always get an odd answer. The same concern happens with g, so I can reject both of those. For m and n, if I add up two odd numbers here in this next problem, then like such as 5 plus 3, those are two odd numbers, I get an even number. I'm looking for an odd number, so that does not work. All right, for part J, if I have two even numbers that I'm adding up, such as 2 plus 4, darn it, I get another even number, so that also does not work. So all I'm really doing is I'm picking values for m and n that match the description for that answer choice, and then seeing if I get an odd number. K is my only option, and by the way, K is the one that works. If you add up one number that's odd and one number that's even, you will get an odd number. Even if there are negatives involved, as long as those are integers, one odd integer, one even integer, you will end up with an odd number after adding. So that answer is K. Number 19, the lengths of two legs of a right triangle are shown. And what we want to do is figure out how far the midpoint from AB would be from point A. So because this is a right triangle and I'm talking about the side lengths of a right triangle, I can use the Pythagorean theorem. And that's A squared plus B squared equals C squared. Those of you who know what triples are, that's going to be way faster than the Pythagorean theorem. So that is another option if you know how to use triples. When you get 32 and you square it and you add on 24 squared, what you end up with is 1600. When 1600 is square rooted, the hypotenuse length is 40. And this is not very nice, but they put 40 as one of the answers, knowing that people would probably use the Pythagorean theorem and find the length of AB. That's not really actually what we're trying to find. We're trying to find half the length of AB, the value from A to the midpoint. So half of 20 or half of 40 is 20. So be careful on that one. You might pick the wrong one. For number 20, we have a triangle, and what we know is how long DE is. Now, I don't know anything about the type of triangle that this is. So this might be acute, might be obtuse, might be a right triangle. I don't know. I do know the side lengths are 30. I know the side length for EF. And they want to know, if we can possibly find it, what is the side length of DF? This is a really unusual question, and the fact that it mentions that it may not be determined should make you very suspicious that maybe this problem cannot be done. And in fact, in this situation, it cannot be done. We would need to know what type of triangle this is in order for us to complete the problem. For example, if it were a right triangle, we could use the Pythagorean theorem, but since we don't know if it's a right triangle or not, we can't use the Pythagorean theorem. So we get stuck, and K is the best answer we can get. All right, number 21. Laura plans to paint the 8-foot-high rectangular walls of her room. Before she buys paint, she needs to know the area of the wall surface that she wants to paint. 2 of the walls are 10 feet wide. The other walls are 15 feet wide. And then we have a window and a door, and together their combined area is 60 square feet. We are not going to be painting the window and the door. We want to find out the wall surface that Laura would need to paint. So kind of an interesting idea is that if you have all these rectangles, and these rectangles all have the same height, which these ones do. These all have a height of 8. If you want, you could actually think of them as one big rectangle. Sometimes I will do that just to save myself a little bit of hassle and time. Put them all together, have one big rectangle. That would only work if they really do all have the same combined, or the same exact height. What we know is one of the walls has a width of 10, the other are 15 each. Oh, sorry, 2 of the walls are 10. There's one more. I'm going to squish it in here. All right, so 2 walls have 10 each, 2 walls have 15. If I want, I could find the area of each individual wall, but I'm just going to go ahead and add them all up along that width. 10 plus 10 plus 15 plus 15 is 50. 50 times 8 would give me the area of all of those walls together, which is 400 square feet. But I do want to remind you, we are not painting the window and we're not painting the door, and they said that those would combine to 60 square feet. So if I subtract them, I have 340 square feet that I actually do need to paint, and that is option B. Question 22, another geometry problem. The length of a rectangle is 5 inches longer than the width, and we know what the perimeter is. We want to find out what the width of the rectangle is in inches. I do better at these if I draw a picture. The length is 5 inches longer than the width. I don't know how long the width is. I'll just call it W. The length is 5 longer than that, so W plus 5. And then they start talking about the perimeter. To find the perimeter of a shape, you need to add up all of the sides. And in a rectangle, the opposite sides are congruent to each other. So I actually have the ability here to write an expression for all 4 of these side lengths. Perimeter is what you get when you combine all 4 of them. So I'm going to go ahead and do that. I'm going to combine like terms for all 4 of these lengths. W plus W plus W plus W is 4W. 5 plus 5 is 10. And together that should total 40. Now I have an equation that I could solve. If I subtract 10 from both sides, 4W is 30. And when I divide by 4, the width is 7.5. And that was actually what they wanted us to find. Be careful, make sure you find what they are asking for. They want the width, and that's what we found. I called it W to help me out a little bit. All right, the next one. 8% of 60 is 1/5 of what number? I'm just going to start with the whole 8% of 60 and find out what number that is. When you're trying to find the percent of something, what you can do is take that percentage and convert it to a decimal. You can do that by moving the decimal place twice to the left, or you can divide by 100 and multiply that by the 60. When I do that, I get 4.8. 4.8 is 1/5 of some number, what that means is that the total number is 4.5 times. So 1/5 of the number is equal to 4.5. So if I do 4.5 times 5, I can find out that my starting number is 24. Number 24, answer, and the next problem are the same number. Okay, Armin is trying to decide whether to buy a season pass to his college basketball team's 20 home games. The cost of an individual ticket is $14. The season pass is $175. The season pass will allow Armin to go to any game at no cost. What is the minimum number of home games that Armin should attend in order to make the cost of the season pass less than the cost of buying individual tickets? We're trying to find out basically like how many games would he need to go to make it worth his money to buy the season pass. Well, the season pass is $175. And since each ticket is normally $14, I'm going to divide that to find out how many games he would need to go to. It ends up being 12.5. Now, you can't really go to 12 and a half games. They're going to make you pay for that extra half of a game, so I would need to round this up to 13 games. 12 games wouldn't work. In fact, if you do 12 times 14, you get 168. You have still not paid the full amount of your season pass. So 12 games is not enough. You have to kind of be careful there and think about how you would round that. You really need to go to that 13th game so that you can get past that cost of $175 and realize it's a good deal. All right, number 25. We are dividing with scientific notation. If you're dividing with scientific notation, as long as both numbers have the decimal place correctly placed after the first digit, you can go ahead and divide those numbers. And you could use a calculator to divide them. 4.8 divided by 1.6 is 3. So we are going to start with a 3, not a 3.2. I'm going to eliminate a couple answers right there. And then what we can do to figure out what the scientific notation would be is I'm going to follow rules of exponents. When we have exponents and we're using division and the bases are the same, the rule is you keep the base and then you subtract the exponents, the top exponent minus the bottom exponent. Be careful here because when you're subtracting these, you're subtracting a negative. At that point, we would end up with 3 times 10 to the power of 4 once you combine those powers, which is option A. 2 more problems. Number 26, we have a circle. And I'm just going to try to draw a picture of this. The circle has one point at -2, 1. I'm sorry, -1, 2. That's point C. And another point at 2, 6. Called point A. So I've got the circle here. And AB is the diameter of the circle. Oh, dang it, I did this problem wrong. Let's try it again. C is the center of the circle. Sorry about that. That's the center. A is at 2, 6. And point B, which would be somewhere on the other side of the center, is going to be also on the circle. That is an awesome circle. C is the center. AB is a diameter. I just want to figure out where B is. First of all, please notice that B would have to be on the other side of point C. So even if you got really, really stuck, if you were able to draw a picture, hopefully better than I was able to initially, you could recognize that 5, 10 and 4, 2 are not in the correct quadrants at all. We really need to be looking in this third quadrant over here and have negative values for both the X and the Y for point B. Okay, from here, I want to actually figure out where it's at. I'm just going to draw kind of a different sketch here where I'm going to say, okay, C is the center and A is one of the ends. I know that this is really a slanted line. I'm going to pretend that it's not. And B is over here on the other end. And I want to find out where B is at. And what I know is since C is in the center is that it's equidistant from points A and B. I'm just going to really look and see how the X coordinates are changing, going from one end towards the middle. Going from 2 to -1, we went down by 3. Because this is equidistant, I would need to continue to go down by 3, which would land me at -4 for the x-coordinate. That's enough for me to choose H. If I did need to finish the problem, I could continue that pattern. The y-coordinates are needing to go down by 4 each time. 2 take away 4 would land it at -2. All right, last one, question 27. I want to figure out which of the following is a factor of x cubed minus 64. This one is a formula that is taught in Algebra 2 classes. So if you've not had an Algebra 2 class yet, you probably haven't seen this formula. Basically, the formula looks like this: a cubed minus b cubed. So if you have two items that are perfect cubes with a subtraction between them, the way you can factor it is you do a minus b. The sign right here will match the sign right here. And then you would do a squared plus ab plus b squared. These are both plus signs. You might have heard teachers say like keep, change, plus, or something like that. That is a common way to describe the signs for positive and negative here. All right, what A is the base of the first term that has been something cubed. In this case, A is 3. So, or A is x. B needs to be the base of the second expression cubed. 64 is 4 to the third power. So 4 is going to be replaced, or 4 is going to be B. So now what I'm going to do is I'm just going to rewrite this. Anywhere where it said A and B, A would be replaced with x, B will be replaced with 4. You might notice at the end I have 4 squared. 4 squared, remember, is actually 16. And I'm going to just check and see if any of these parenthesis sets are showing up in the answers. X minus 4 is showing up. That is the one we want. D is really, really close. We just have a sign error that's not supposed to be there. All right, so that is it for page 26 for this ACT review.